All right, this is video for 7-6 for geometry. Hi, everybody who's at home or whoever's watching this. 7-6, they have a lot of theorems to start with. We're going to go kind of through these very briefly, but I'll show you kind of how they boil down. These two triangles are similar to each other, okay? And what we're doing is setting up proportions. That's kind of a common theme for the last couple sections, is setting up proportions, solving for unknown things, okay? Do you guys know what this thing is called? What this line right here is called? He is straight down, perpendicular with the bottom. He's called an altitude. If this is an airplane up here, these guys are my airplanes, okay? At the vertices on top, they are straight down to the opposite side, yeah? Okay? Straight down to the opposite side. So, when I have parts going on like that, they say that AD over, like, let's say, FJ, and AB over FG. So they are saying, like, this is X, and this is Y, and this is, I don't know, Z. Well, let me just do this. If that's X and that's Y, and this is 4 and this is 2, I could go X over Y equals 4 over 2, okay? Even though that middle part inside of there, that altitude, is not, is kind of an addition to the triangle, I can use that, because I know these triangles are similar, I can use that to develop a proportion, yeah? And set them equal, and then we cross multiply and do all that stuff, okay? So if by chance I would tell you that, like, let's say Y was instead, let's say Y is 6, what would X be? 12. I was hoping somebody was going to say 3. I almost did. You almost said? Okay, well, I was just looking at 4 over 2 is 2, right? So 12 over 6 has to also be 2. That's not going to be a little good. That's okay. Okay. So we can set up proportions that way and solve, right? Okay. So the altitude is also considered a part of the triangle. These are parts of similar triangles. Any of the parts, we can set up a proportion as well. Set up proportion, and the proportion will still work. Good? All right, let's go to the next piece. This guy right here, what is this thing? These two lines. What is it bisecting? It's an angle bisector. I'm going to write that on here. Angle bisector. Okay, this guy is an altitude, and this guy is an angle bisector. And what I can do is any one of these sides, so let's say I look at those two pieces of the triangle. Let's say that this guy is X and Y, and this is 4, and this is 2. I could say that X over Y is equal to 2 over 4, right? In that case, I'm going top to bottom, top to bottom. I could also do X over 2 with Y over 4, and that would work if I go left to right, okay? But what it's saying is, even though you have those pieces inside of a triangle, you can set the pieces over top, or any of the parts, set them up as a proportion also. Not just the two outsides of the triangle, that type of thing. Okay? All right, last one. What is this thing? What's that line? This one's a hard one. He is a, somebody said it, median. The median goes from vertex to midpoint. How do I know that that's the midpoint to the opposite side? Because of these guys, right? That shows that these two sides are the same as each other, and these two sides are the same as each other. Now, are these sides the same? No, but they're the same as each other within each one of the triangles, right? Okay. So if I have those guys labeled, like this is an X and this is a Y, and let's say I'm talking about this other side over here, doesn't matter. And this is a 4 and this is a 2. I would say X over Y equals, would it be 4 over 2 or 2 over 4? 4 over 2, because X is the top one, so I want to go top to bottom, yeah? So it's just saying that if you have any of these parts, an altitude, an angle bisector, and median, you can use that as a part of your proportion because those triangles are similar. Good? Okay. Let's do an example. And now they turn the triangle on you. So it's on its side. Great. But here is what, if you have any question, refer back to this statement, because that means that A goes with which one? F. So A and F are the same, if that was ever any question, right? B goes with D, C goes with G, so that's how he is turned. So technically it's kind of turned and flipped, right? D goes with B, so he should be the opposite direction, okay? What? No, it's not a median. What is it?
It's an angle bisector.
It's an angle bisector. Okay, let's write that down. This guy right here is an angle bisector. No, I'm just writing it down in your notes so it's easier to distinguish. Angle bisector. Okay? All right, so on your homework assignment, it's a good idea to set up what is equal to what, right? Okay? And I usually do like circles and circles and squares or underlines and circles or whatever. So X, what does he go with? 8. Okay? 15 goes with 12. So that's my like coding there. If you want to use different colors, you sure can. Like circle these two in purple, circle those two in green, doesn't matter. Let's set up a proportion. Sure, X over 8 equals 15 over 12. Now, you will get the answer wrong if you go X over 8 equals 12 over 15, right? We went left to right by doing X over 8. You've got to go left to right the other way, right?
I feel like I'm doing it wrong.
You feel like you're doing it wrong?
Every time I do it, I feel like I'm doing it wrong, but apparently I'm not.
12X equals, is it 120? Yeah, you're right. Divide by 12. X is 10. There you go. Okay. Okay. All right. Back side. Are we ready for the back? Okay. All right, and then we have a story problem. Oh my gosh, oh my gosh. Okay. All right, you guys have all done this before to figure out like whether you're right eye dominant or left eye dominant. Have you done that? No. Do you know? You don't know?
Yeah.
If you are like a trap shooter or something, you definitely know which eye dominant you are. Okay, so here's what I want you to do. Turn to the clock. Okay, you people that are watching this video, you might not be able to do this or find a clock at your home. I don't care. So what I want you to do is keep both eyes open. Keep both eyes open and do one of these like a little triangle and put the triangle over top of the clock. So that it's just over top of the clock so that you can see the clock through your triangle. Can you? Okay. Okay. So through your triangle with both eyes open, can you see the clock? Okay. Both arms straight out in front of you. Okay. All right. You ready? Close your left eye.
Yeah.
Close your left eye. Does the clock move?
No.
No. Okay. Now close your right eye. The clock should move so that you can no longer see it.
It's not there.
It's not there?
Yeah.
So Elena said. When she closed her left eye, the clock did not move, right? But when she closed her right eye, like her hand is now covering the clock, right?
Yeah.
Which means that most of her vision is controlled by her right eye because everything that you see is coming from the right eye. Okay. If it's different for you, if when you closed your right eye it didn't move, then you're left eye dominant. Okay. And that's just the way that it goes. Okay.
Most of the time, if I lost my right
Most of the time, if you're left-handed, you're left eye dominant. So you're what?
I'm right-handed.
Really? Do you shoot with your left?
Yeah.
On your left side, you really do?
Yeah.
Yeah, that's cool. So like trap, you shoot trap though, right? Yeah. So John shoots trap. He's left eye dominant, even though he's right-handed. So he's kind of a weird combination. That's okay. He shoots like for trap shooting. He shoots and scopes out of his left eye because it's like a sharper eye, I guess, than the right side. Does that make sense? Okay. So what's happening here is she's taking here's her eyeballs. Her eyeballs are 10 centimeters apart. Okay, well, not really, not 10 centimeters. That's a big face. 10 times longer than the, whatever. Okay, we'll get to that. She's holding her thumb out in front of her, and what's happening is she's looking at a car here, and she's closing her eye, and the car jumps all the way over here. Okay, kind of like what the clock did. The clock moved when we closed our eyes. Okay, whichever one you close. So let's read some of this information and see what we've got. Liliana holds her arm straight out in front of her with her elbow straight and her thumb pointing up. Closing one eye, she aligns one edge of her thumb with the car. She is sighting. Next, she switches eyes without moving her head or her arm, and the car jumps from here to here. Okay? The width of the car, of any one car length, is how wide? 5.5 feet. Okay? So keep that in mind. Just one car length is 5.5 feet. So keep that in mind. Okay? All right, the car appears to jump 4 car widths, okay? So when it jumps 4 car widths, what does that tell me?
5.5 times 4.
5.5 times 4 is,
Yeah.
22. 22, okay? 5 times 4 is 20. Half of 4 is 2, so 20.
What?
So from here to here is 22, yeah? 4 car lengths, and each car length is 5.5.
Oh.
So 22 lengths. All right, that's bigger over here. 22 feet is how far it is jumping. The one car jumping to the other car. 4 car lengths. Okay. The car appears to jump 4 car widths if Liliana's arm is about 10 times longer than the distance between her eyes. So it's not saying that one is 10 and the other one is like 1 centimeter. It just says a 10 to 1 ratio. Okay, so if our eyeballs are, I don't know, 3 inches apart, then from here to here is 30 inches, right? Because it's 10 to 1 ratio.
Oh.
Her eyeballs are 10 apart. Her thumb,
You said 3.
What?
You said 3 inches.
yeah, but it's a 1 to 10 ratio.
Oh.
Okay, so if her eyeball, like the distance here is 1, the distance here is 10. If the distance here is 3, the distance here is 30. Does that make sense? It's a 1 to 10 ratio. So that means this guy right here, we're going to write it as a 1. That doesn't mean 1 centimeter, that means 1 scale factor, right? From here to here is 10. So maybe it's 3 inches and 30 inches. Or maybe it's 4 inches and 40 inches. Or maybe it's, I don't know, 7 centimeters and 70 centimeters, right? It's a 1 to 10 ratio. Okay, they are wanting us to find this distance right here. Woo! Okay. Okay, so we've got to look at our 2 triangles. We've got pieces here. What are these? What parts are we looking at, by the way? Like, what is this middle line? What is that thing? That's an altitude. Okay? This guy is technically an altitude because he is perpendicular straight down. Okay, perpendicular straight down to the opposite side. If he was facing upright, that is an altitude. A vertex to bottom, perpendicular. Okay, altitude. So we have to decide what over what. Okay, so let's talk about 1. What does 1 go with?
5.5.
22.
22 technically. We have to change it to 22, right? Because it's 4 lengths, so 22. 1 goes with 22. What does 10 go with? X. I'm going to put a box around him and a box around him. Okay? If you get stuck, color code it or box it and circle it. Okay? So you can see what goes with what. Then we just have to set up a proportion. 1 over 22 equals 10 over X. Now she went which direction?
Left or right?
Left to right. She go to left to right both times. Left to right, left to right. Yep. Okay? So, 1 times X is just X. 22 times 10 is 220. What does that mean? That's the distance in feet from what to what?
From eye to car.
Not from her eyes to the car. From her
thumb.
thumb. From the end of her thumb to the car is 220 feet. Yeah? That distance there? Okay. All right, so just look at the 2 triangles that are set up, yeah? All right. Triangle angle bisector. Let's see how this is different. They say KM. Oh, good. Okay. Triangle angle bisector. So here's this segment right here, and it's bisecting that angle. Now, do I necessarily know that this length here is the same as that one? No, but what I do know is if that is bisecting the angle, then this over this will be the same as this length over this length. Okay, I can set up the pieces. So this length won't be the same as this one, but if I do the proportion of this over this, it has to be equal to this over this, right? Okay. So if I do like 2 over 4, and I do that this is 3, this guy has to be 6, right? Okay. I would say like 3 over 6 is equal to 2 over 4. The pieces in relationship to each other are proportionate, right? Not exactly the same, even though the angle is the same. But this over this has to be equal to those 2 longer sides in proportion to each other, yeah? Okay? All right, so this is where the confusing part comes in, because you're like, what do I put over what? Example 3. Here is the angle that I'm bisecting. So I'm going to draw my angle bisector. There he is. Okay? I'm looking at my 2 pieces. Okay? So let's talk about these 2 edges right here. One of them is X. So this guy is X. What is this length right here?
9.
Nope.
No.
We don't know that it's half, right? Okay, because this one obviously looks longer than this one. So this is x. How long is this?
X.
X2, 2x, 2 plus
No.
x.
Yeah, is it
You're
Y?
close.
18 minus
18 minus x. If this is 10, then this is 8, right? If 18 minus the x will give you that spot, right? You don't get that? Okay. 18 minus x. So, here you go, Lily. Let's say for pretend, Lily. For pretend. Don't write this down, but for pretend for Lily. Let's say that this guy right here is, I don't know, 4. The whole length is 18. If I take 18 and subtract 4, I get that this guy is 14, right? Okay? But we don't know that it's 4. We only know that it's x long. So we just write it as 18 minus x, because that's what you would do to subtract it, right?
Because 18 is the whole length.
18 is the whole length. Okay, so don't write the 4 and the 14 in there. Okay, because we don't know that it's 4 and we don't know that it's 14. That was theoretical. Okay? All right, so now let's see what parts I can put over what.
18 minus x over 14.
Okay, so she wants to do 18 minus x over 14. Sure, as long as you set up the other one correctly.
I have to go over
So she did 18 minus x over 14. She has to do what else? X over 6. Okay, before we solve that, okay, she went left to right, basically. I could have gone top to bottom. That would look like x over 18 minus x equals
6 over 14.
6 over 14, right? I could have done it that way too. And you would set up the same proportion, right? Because no matter what, I'm taking 14 times x. No matter what, I'm taking 14 times x. No matter what, I'm taking 16 times this guy, or 6. No matter what, I'm taking 6 times this guy. So it doesn't matter which way you set it up as long as you go the same direction. Okay? So, cross multiply. 14x. What is 18 times 6? 108. Minus x.
108 equals.
Would it be 6x? Or would it just be x?
Add X. Wait, what is happening?
Elena got tricked. When you are multiplying, you got to distribute. So it shouldn't be 108 minus x. It should be 108 minus 6x.
I thought you were just asking what to do next, and I was like,
Okay. All right. So there we go. All right. Add the 6x.
I'm done.
20x equals 108. Divide by 20. Divide by 20. X is 5.4. Check me.
Yeah.
Is it really? Ha! I did that in my head. Do you know how to do that in my head?
No.
What's 100 divided by 20?
5.
5. 8 over 20 is 4/10.
Are we supposed to be?
We're not mathematicians.
Wait.
Try to do some of these in your head.
Wait, Allie.
Allie, shut
How-
up.
How are we?
How did you do it, Allie? And then half of that? Sure, yeah. So she
Wait.
did 108 divided by 10 is 10.8. But then half of that is 5.4, right? Yeah, that's a good point. Good job, Allie. All right,
Why are we-
there you go.
Wait.
Why do we have to spend time on those?
What?
Why are we adding 6 and subtracting 6?
I mean, that's what we got calculators for a reason.
What?
You have to add it back over. Oh, that's fine.
You're supposed to
Oh, she supposed to have it plus 6 on the
not minus
Oh.
6.
Oh, good
other side.
call.
We do.
Yeah, I don't know why I put minus. There should be a plus 6 on both
I was
sides.
kind of scared.
Yeah. You know, go with what I did, not with what I wrote, right? All right, everybody tell the people watching this goodbye.
Bye, guys. You're on
Bye,
fire.
Ellie.